This video is going to work through an example or two of Hooke's law. Okay, let's say we have a spring, and maybe we don't know the spring constant. What we do know is that it has a natural length of, let's go with 8 centimeters. We find when we attach a mass of 2 kilograms to it, this thing stretches to 10 centimeters. And now I would like to know, how far will this spring stretch if I hang 5 kilograms from it? So let's do this. We can do this a couple ways, but let's do this way first. So I'm going to take this spring and I'm going to hang 2 kilograms from it. When I do that, the spring stretches to 10 centimeters. So looking at the forces on this thing, I've got an mg downward, I've got a kx upward. I'm going to call upward my positive direction. And there's my free body diagram. Kind of included the picture itself. When I draw my sum of forces, when I write my sum of forces equation, I'm going to get k times x minus mg equals mass times acceleration, which is going to be 0. So I can solve. I get k equals mg over x. This thing has a natural length of 8 centimeters. And when I do this, when I hang this 2 kilogram mass from it, it stretches to 10 centimeters, which means my x is going to be 2 centimeters. I'm stretching 2 centimeters from equilibrium. So 2 kilograms, 10 meters per second squared, divided by my stretch, 0.02 meters. 2 times 10 is 20 over 0.02 is 1,000 newtons per meter. That's my K value. Now I want to know what happens when I put 5 kilograms on this thing. So now if I put 5 kilograms on here, my free body diagram is going to stay the same. But my sum of forces, I'm going to get K times x. I now don't know how far I'm going to stretch. Minus mg equals ma. Acceleration is still 0, so I'm solving for x now. X is mg over k. 5 kilograms over 1,000 newtons per meter, and I get 0.05 meters. This thing is going to stretch by an additional 5 centimeters. So x displacement magnitude is 0.05 meters. The whole thing has a length, a natural length of 8 centimeters, so it will stretch to 13 centimeters. That's it. That's how I'm going to do Hooke's law problems. I can also do these the same way with compressions instead of stretches. If I wanted to compress the spring by 5 centimeters, I would need to apply the same amount of force. I would still need to apply that 50 newtons of force, 5 kilograms times 10 meters per second squared. 50 newtons of force when hung from here makes this thing stretch by 5 centimeters. if I wanted to take the spring from equilibrium and compress it by 5 centimeters, I'm going to need to apply 50 newtons of compression force. It works the same way in both directions.